47 was a little different, and 47 we'll actually look at a problem similar to this today. But the directions, sometimes they're going to seem a little crazy. You'll get used to reading the book's directions, I promise. Like after you get through a chapter, you'll kind of understand what they're trying to ask for, even though they use crazy words. I know if I wrote the book, I'd probably ask it differently, but if I wrote the book, you wouldn't have me as a teacher because I'd be writing books instead. So lucky for you, I don't write books. So for number 47, the directions say use a graphing utility. Why can't they just say use a calculator? Graphing utility. To graph the three functions in the same viewing window. So you're graphing three functions in your calculator. Describe the graphs of g and h relative to the graph of f. So essentially, what's the difference from g to the original function f? What's the difference of h to the original function of f? That's what we're trying to do for this problem. So in order to graph that, if you look at what they give you for g, so the function g says take f of x plus 2. What does that really mean that you're doing? So thinking back to like what we did the last two sections, sections 1.2 and 1.3, what do you do if it says f of x plus 2, Libby?
Substitute x plus 2 x from f of x.
Yeah. So whatever is in parentheses is your x that needs to be substituted into the function. So g of x is a new function we're creating, and that function is becoming x plus 2 cubed minus 2 times x plus 2 squared. As it says x cubed, so I have x cubed minus 2x squared, so now we have minus 2x squared. We just replaced x with whatever's in parentheses. Now, instead of foiling this and going crazy and trying to simplify, I actually want you to keep it like this, which will probably be the only time this year that I tell you not to simplify. Because the goal is to have this piece in the problem so that we can kind of notice, without even graphing it, what might happen to the graph. So if you had a problem that said x plus 2 cubed, and it didn't have the extra jazz being subtracted back there, how would you say the graph should move? Virginia?
To up. No, wait. To the left.
To the left. So my problem just said, I'll use a different letter here. We'll go with a k. So my problem was k of x equals x plus 2 cubed. That graph should move to the left. Because anytime you take something in place of x, you replace it with an x plus 2, it moves the opposite direction because whatever's being done to x affects the x variable. So the x is shifting to the left too. Knowing that, if we have x plus 2 cubed minus 2 times x plus 2 squared, Virginia, what do you suppose would happen with that graph?
It would still just move left 2.
It still just moves left too. Because whatever you do to one x, you do the same thing to the second x. If I had 5 x's up here, I would do the same thing. It's still shifting the graph to the left. No matter how huge your equation is or how basic your equation is, which in this case, that's considered a basic equation because you just have one x. So if we add that minus 2 squared, it's not changing your graph. Besides shifting it to the left too. Right.
I think the equation is x cubed minus 3x squared.
Not 2x squared? Oh. Thanks, Brennan. Alright. Oh, same difference. Oh, thanks, Brennan. Looking out for me there. So when you graph them, if you did graph them in your calculator, you should have seen the first graph, which looks something like this. The second graph still looks something like this, it just shifts to the left. The shape doesn't change, the location of it vertically doesn't change, it doesn't get wider or narrower, it just shifts to the left. So literally the graph is moving to the left because of that x plus 2. So the next one says h of x equals 1/2 f of x. So the tricky part maybe was trying to figure out how the heck you're supposed to get this in your calculator. If I have x cubed minus 3x squared, happens if you're supposed to take 1/2 f of x?
You put 1/2 before.
Yeah. So you put 1/2 before it. And I'm just going to put it in parentheses and say I'm taking 1/2 of all of this. Because if you're taking half of f of x, well, f of x is x cubed minus 3x squared. I need to take half of all of that. If you wanted to distribute it through, you can, that's fine. What happens if you're taking half of something to the graph? So what would happen to the graph? It becomes smaller. Because this part here, if you're taking half of f of x, you're really taking half of y. All of the y values are now smaller. So that curve wouldn't have been nearly as steep because my y values are cut in half. So if I multiply x cubed minus 3x squared by 1/2, the y values are still being cut in half. Because whatever you plug in for x, I now have to take half of that answer. So she said it was getting smaller. Maybe you said it was getting more narrow. That's what you said, right? It becomes smaller?
Mm-hmm.
The curves wouldn't have been as steep. It does get wider than yes. So vertically, it becomes smaller. So we'll say vertically here. Because the y values are getting smaller. So vertically, since we're affecting y, vertically it becomes smaller, but Virginia said wouldn't it get wider? And yes, the graph actually would spread out more because it's not nearly as steep. Any questions on that? So that's what that question was trying to get you to do. So can you take whatever's in parentheses and replace x for that? Or what does it mean if you're taking 1/2 times f of x? Well, it really means you're taking half of y. So if we take half of y, all the y values you have are going to be cut in half. So if my y solution was 10, now it's 5. Are there other questions from the homework? Your quizzes are graded. They're in Power School. I give them back to you Monday. They just have a student making it Monday morning during it. You can check that out on Power School if you haven't already. Did you guys get a notification like? No? Yes? Can you set that up to get notifications that a grade has changed? Or like is it you get notified if it's below a certain grade? I don't know.
You get notified like if it moves up or down. So like if you're like at an A minus and it moves to an A, then I'll tell you. Or if, like if you're at like an A that moves down to an A minus, I'll tell you that.
Okay. So you don't get a notification that it changed if it didn't really change the letter grade. We're going to look at some graphs today. We're going to start with reflecting graphs. So in your notes packet, should be on the back of the page that we did yesterday. So yesterday we just looked at problems that shifted left, right, up, down. I did that really quickly, and just a quick little review. So we'll also look at reflections, and then there's stretching or making a graph wide, making it narrow. But the first term we have here is a reflection. What's another word we could use for a reflection, Brandon?
Flip.
A flip, yeah, that's usually what you call it. You can also think of it as a mirror image of the original graph. So if I have 1/2, it's going to be mirrored on the other side. Just like you look in the mirror, you see your mirror image of yourself, you see a reflection of yourself, or a flip of yourself. I'm not sure why there's a whole bunch of space there. Like a lot of space for a little definition. Maybe because we could draw a picture. So underneath it talks about two different types of reflections. We're going to reflect over the x-axis. We're going to reflect over the y-axis. We could reflect over the origin too if we wanted, but we'll just look at reflecting over these two things. So for a reflection on the x-axis, since there's some space up here, we might as well draw ourselves just a tiny little graph. If we had just half of a parabola, say that's what it looked like, and you were reflecting it over the x-axis, or reflection in the x-axis, what happens to that graph, Brandon?
It goes negative and then it's just gonna go down, you know?
Okay, so you said it goes negative. So if you have an ordered pair, Brandon, what
Very
goes
short.
negative?
Yes, the y values.
The y values. So for a reflection in the x-axis, the y values become negative. So your original point is positive x, positive y, wherever that happens to be on your parabola. That point now has flipped over the x-axis and your y values become negative. They still start at the same location. If it's at the origin, they'll still start at the origin. It's just not all those y values are going down. X doesn't change. So with your ordered pair, you're making the y value negative. Literally, you're multiplying it by -1 to get a reflection. The way that you'll see it written as a function, if it's a reflection in the x-axis, if I'm making y negative, that means the whole function is becoming negative. That's another way of saying make y negative. So you will see negative and then f of x. Your whole function's becoming negative or your y is becoming negative. They mean the same thing, just using different notation. The second one underneath is the reflection in the the y-axis. So again, we'll make a little sketch here. We got some space, same graph. So reflection in the x means the graph is flipping over x and now facing down. A reflection in the y means the graph is flipping over the y and now it's on the left side. So our original point, the x values are now negative. But it's at the same height. Height hasn't changed, it's flipped over the y-axis, meaning we're on the negative side of the x-axis. As a function, that will have a negative literally with the x. So if it was x squared, I'd have parentheses, negative x, and then squared. So you'll see the negative being attached to the x. That tells you that it's a reflection in the y-axis because all the x values are becoming negative. So I believe there are 3 graphs underneath there. But before those 3 graphs, you have to remember what a square root graph looks like. So think of the little quick graphs. This graph is not moving, it starts at 0, 0. And then you're taking numbers and you're placing them in and you're taking the square root of that number. So use numbers that you can take the square root of to make a little sketch. Like the square root of 1, so over 1, up 1. Or the square root of 4, so over 4, up 2, because the square root of 4 is 2. Brandon, we could also take the square root of 9 and go up 3. If you can quickly recognize what the picture looks like in your mind, which Mr. Kane has like not quite a photographic memory, but he's very darn close, which is annoying. But some people have that. If you can try and like quickly recognize a square root means it's going to hook this way, parabola means it should be a u, absolute value means it should be a v. You're going to have more time on your test to focus on the harder things. So quickly being able to recognize a graph, the way it moves, so that you can solve the other part of the problem. It is one of the things that I'm going to try and work on this year, because our goal is to solve the hard things. This stuff needs to be in your memory bank. It's a little picture in that head. Ask Mr. Kane any baseball stat from like the 1910s, Jen, on Monday. Like 1910, who was the best baseball player? What was their number of home runs? He'll tell you. Seriously, he will. It's crazy. He like must have sat and just read through baseball almanacs as a kid. From the 1900s, like early 1900s, because everybody wants to know like about a baseball player in 1910, right? I'm not lying. I'm serious. Don't write a baseball paper. Nothing about baseball. You will fail because he'll tell you it's wrong in some way. Little tip there. Never write anything about baseball. All right, so looking at the three graphs down below. Nick, you didn't write about baseball last year, did you? Oh, good. He always catches somebody with that. The first one, we have g of x equals negative square root of x. So before you even graph it, can anybody explain the reflection? So that's the one thing we want to look at. Sabrina.
It'll be on the x-axis.
So she said it's going to reflect on the x-axis. What becomes negative in this?
The result of the square root of x.
Okay, so the result of the square root of x. So she said we're reflecting over the x-axis because your result, which is the y, is what's becoming negative. So our original graph was above the x-axis. Oh, still can't see it. Now it's below the x-axis because the result is becoming negative. So if I take the square root of 1, it's usually 1, but now there's a negative sign in front of it, so it's negative 1. The square root of 4 is usually 2, but there's a negative sign in front, so it's negative 2. So the negative outside means the y values, your answer is becoming negative, so it's reflecting over the x-axis. Looking at letter B, you can see the difference between the two. Now the negative is underneath the radical. It's with x. So when it's with x, the x's are now becoming negative. So we're reflecting over the y-axis. And that has to happen. I need to be able to put negative numbers in there because there's already a negative in front of x. And the double negative would make it a positive number, so we can take the square root of it. So same graph as above, but now it's flipping over the y-axis. And then the third one, we have negative square root of x plus 2. Brandon, what topic was that?
First you put it midpoint at -2, 0.
So we're moving left 2.
And then you just draw the same graph as the first one, just starting at -2.
Excellent. So it's the same graph as the first one. It's just starting to the left at -2. But it's still reflecting over x because your y values are becoming negative. Any questions with reflection? So just kind of notice where the negative sign is. If it's outside, you're affecting the answer. If it's inside, you're affecting the answer. So at the top of the next page, there is a vocab term called a rigid transformation. Anybody remember the types of transformations? Like, how can a shape change? What could you do to a shape? Brendan?
You could scale it, make it larger or smaller.
So he said you could scale it. What was the word used in dilation when you had like a scale? I gave it, never mind. In geometry, the word was dilation. When you gave it a scale, you either scale it to make it bigger or smaller. That was the geometry word you used. So you could change the size of the shape. What else could you do? Huh? You could slide it or shift it, left, right, up, or down. Sabrina? You could rotate it. Or, Brandon?
You could flip it.
You could flip it. Those are your transformations. A rigid transformation either changes the direction that it's going, so it either flips the graph, or it slides the graph, or shifts the graph. So rigid transformations are your flips and your shifts of the graph. But there is no change in size or shape. tells you that there's actually an order in which you perform these rigid transformations. And this is what you're going to have to think about for your homework tonight. So when you're looking at your homework, probably not tonight, probably on, maybe Sunday night, Monday morning in homeroom. Hopefully not Monday morning in homeroom. Brandon, which one of those two do you think you do first?
Flip.
Why?
Because if you shift it and it shifts over one of the axis, then you can't really flip it anymore.
So the other reason that you would want to flip or reflect it first is because you're literally taking one of the variables and you're making it negative. If you make something negative, you're multiplying by a negative 1. Multiplying goes before adding or subtracting, which is what shifting it does. Shifting it adds something left or right, adds something to make it move up or down. So when you change a y value, you multiply it first by a negative number because PEMDAS says multiply before add and subtract. So you multiply first, then you would add or subtract your number. So you shift second. But you flip or reflect it first. And sometimes it doesn't pertain to every graph, but there are specific ones that you have to make sure you're applying that negative first, especially if you're just looking at a set of ordered pairs. So multiply first before adding or subtracting. Any questions on that? So we have this function f of x equals x cubed. These problems look a little different. So they're telling you what the original function is, and then we have that function notation like number 47 that we went over together at the beginning of class. So it says for a, we're supposed to take f of x minus 4, which really means our function says x minus 4 cubed. If I was writing in my equation form, we're just using function notation to represent it a little differently. It doesn't mean anything different, we're just writing it a little differently here. So Nick, what does it mean if we're supposed to take x minus 4 cubed? How's the graph move?
So the minus 4 puts it to the right 4.
So this moves it to the right 4. Okay. Now we need to think about what the graph actually looks like. So the x minus 4, no matter what graph we're dealing with, is going to move it to the right 4. That's what f of x minus 4 means. You have a graph, it's moving to the right 4. What's the shape of this graph?
It's that's squiggly shape.
Yeah, that squiggly shape that just kind of goes up the whole time. It starts the bottom left, goes to the top right. So if you start at 4, 1, 2, 3, 4, you're now applying the cube power to your new point. So over 1, 1 cubed is 1. Over 2, 2 cubed is 8. Backwards 1, negative 1 cubed is negative 1. Negative 2 cubed is negative 8. That's how you get that curve that stretches. So looking at letter B, we have negative and then f of x minus 4. So it's still moving right 4, but Chelsea, what else is going on besides moving right 4?
It flips over the x-axis.
Yeah. And that happens because the negative in front. That means your answer, your solution is negative. All the y values are negative. So you're taking the x value and moving it down. Not x, how about y? Taking this y value and moving it down, because if it was positive, it becomes negative. If it was a negative y value, it becomes positive. So the graph, the top part's flipping down, the bottom part's flipping up, since it's flipping over the x-axis. Make sure you flip it over the x-axis. Here we go. And then the last one looks a little weird because they give you two different functions and they're telling you that it's equal to each other. So the left side says you have f of negative x plus 4. But then on the right side, they're saying that same thing means negative x minus 4. Why are they the same? Libby?
Because in the second one, so the one on the right,
Mm-hmm.
the x or the negative would go into the x, so it would be negative x plus 4.
Yeah, so if an x is negative, that means a negative was applied to whatever's in parentheses, because if you apply a negative to one part of a parenthesis, you apply it to all of them. So even though, if you're given this piece right here, you're going to look at it and be like, well, that graph should move to the left 4. But it actually doesn't move to the left 4, because if the x is negative, that means a negative was applied to the x, and it was applied to the 4. So if you factor out that negative or pull out the negative and look at it separately, really inside you have a positive x and a minus 4. And this is tricky because automatically you want to say the graph is moving left because there's a plus 4 in there. But this graph still moves to the right. Because if you pull the negative away, it still is in front of the x, but separating it from the x and the minus 4, or the x and the plus 4, if you pull that away from it, it does become the x minus 4. Brandon?
So before you do it, you should always just try to make x positive.
Exactly, that's what I would say. So if there's x, if there's a quantity, negative x plus 7, negative x minus 7, I would always pull that out and keep the x positive. That way you can see the shift of the value of the graph. So this graph is going to reflect over the y-axis. It's still moving right 4. So even though it has a plus 4 in there initially, by pulling that out and making x positive, it's still moving to the right 4. And we're reflecting over the y-axis, which in this case, the y-axis is technically with that 4 because we've shifted the graph. So my original graph, the top half is now flipping to the left, the bottom half should flip to the right. So it should kind of look like this if we were showing the flip. So the top point was over 1, up 1, now it's left 1, up 1. Or left 2, up 8. But you notice that B and C are actually the same exact graph. That doesn't happen for all of them. So a reflection over the x-axis is going to be different than a reflection over the y-axis. And you could see that on the previous one we did. It's definitely a different reflection. But because of the way the graph splits, a reflection over the x and a reflection over the y happen to look exactly identical over that graph. That happens with every x cubed graph. Questions? So I want you to see what you remember about absolute value. See if you can graph those two absolute value problems at the bottom. And then we're done graphing. We're going to skip the last two graphs and we're just going to try and look at some algebraic equations and just kind of describe how they're moving. So how do you graph an absolute value? What do you remember about graphing an absolute value? Chelsea?
It's a V.
It is a V. So these graphs, both of them should be a V. Chelsea, does the vertex move anywhere? No. So the graph isn't shifting because there's not a plus or a minus. So this V starts at 0, 0. What about the number in front, Chelsea?
It increases it.
Yeah, that increases it. And that's because it's a V, you have two lines that are meeting at the vertex. So that 3 is kind of like the slope of both of those lines. So think of it as moving up 3 over 1. So from the vertex, up 3, right 1. Or up 3, left 1. So you're always moving up and over, but you're either moving over left or over right. We call this a vertical stretch. So usually you think, yes, this has gotten more narrow. It's skinnier. That's how we usually think about a graph. Now we're going to try and think about it being pulled vertically because of the steepness of the slope. That number in front is the steepness of the curve, the steepness of the graph, the steepness of the slope, whatever you want to call it, but it's the graph being pulled vertically. This happens with a vertical stretch when your A is greater than 1. That number in front, if it's bigger than 1, it's being stretched vertically. Because you're rising further than you're moving left or right. So then with the 1/3 absolute value of x, now you're only moving up 1, but you're going left or right 3. So the steepness of it has now shrunk because the graph is actually getting wider. So you're going up 1/3 in both directions. And yes, I know this graph is getting wider, but we call it a vertical shrink. That happens when A is between 0 and 1. Right. Sure. So A is bigger than 1, it stretches, it's being pulled vertically. When it's between 0 and 1, it's a fraction, 1/3, 2/3, 4/5. Anything less than 1, it's being shrunk vertically. So yes, I know it's getting wider, but vertically it's like squishing down. Questions? So the last couple of problems we're going to look at, we're going to skip the last 2 graphs. I changed this packet, saved it as a Word document, but never resaved it as a PDF. And when I send it to the Copy Center, it has to be as a PDF. So my notes that were changed, you don't have in your packet. It's kind of sad and frustrating, but it happens. So we're going to do example 6, and then instead of us doing example 7, we're going to try and create our own example just to help you a little bit with the homework problems. So example 6 says, given the function x cubed plus 2x, similar to what was in the homework for number 47. What happens to the graph? And if you look at the notation, you see that function notation, f of x plus 2. That means it can be referred to any function. In this case, we just happen to be referring to x cubed plus 2x. That part doesn't matter though. What would happen to any graph if it said f of x plus 2? Chelsea?
It moves left.
Yeah, it moves left 2. And that's why we're starting to use that function notation, to get you to realize that it doesn't matter what the function is. As long as the x plus 2 is grouped together, it's moving it left or right. So the middle one has a 2 in front. Kayla, what do you think that 2 in front would do to the function? Mm-hmm. Yeah. Because this is your A, and that's bigger than 1. So it's stretching it, pulling it vertically. And then the last one, if your x is negative, what's happening to it? What kind of reflection would it be if the x is negative? Yeah, Alice?
Or the y-axis.
Yeah. So it's reflecting over the y-axis. So we're going to skip the last couple problems. You do not have to write these problems down. I just want you to kind of look to see what they kind of look like. They're not in your packet. They should have been. Totally my fault. So the last part of your homework on that worksheet, the last 6 problems, are kind of similar to this. The wording is very similar. You have 2 functions. One function is x cubed. A second function is the square root of x. The directions say express each as a transformation of f or g. So essentially, we want to write them in this function notation. There's 2 functions given. F is x cubed, g is the square root of x. So the first thing you have to do is look at your equation and decide is it function f or function g. So for letter A, if it's x minus 4 cubed, I would choose f, because it matches function f. And then you're going to write it in function notation. Again, this isn't in your packet, just kind of just look to see what we're doing. So instead of writing it as x minus 4 cubed, we would just use f, because that represents a cubed function, and in parentheses, it would just become x minus 4. That's now in a function notation instead of the equation. And that's it, like that's all you're doing. So if we look at a harder one, like down here with letter D, it's a square root. Well, The square root function is the function g. What goes in parentheses with x? Well, what's under the square root? X minus 2 is under the square root, so that goes with x. What else happens to g? Chelsea?
It's a plus 6.
It's a plus 6, so you can put it in the front, you can put it in the back, and it's negative. So the last 6 problems of your homework, there isn't any work you're doing, you're just writing it like out of equation form into this function form. You're going to use F or G or H or K, whatever letters are kind of being used in the function. Questions with that? It's a little different kind of writing it out of function. Have an awesome weekend. Thanks. A lot of notes for